Hello, dear students. I'm glad to meet you at our course. Today we are going to discuss cement and concrete. Let's start. Cement is often confused with concrete, and it's a common misconception that cement and concrete are interchangeable terms. Cement is an ingredient in concrete. Cement, which is the glue that binds concrete together, is a fine powder made up of crushed minerals such as limestone and clay that function as a binder. Cement can be made from a variety of materials, but it can't be used on its own. In fact, Roman cement was crushed rock with burnt lime, volcanic ash, and brick supplements. Today, Portland cement is the most common cement used and is one of the lowest cost materials around the world due to the widespread availability of limestone and shales. Concrete is the final product resulting from mixing cement, aggregates, usually sand and gravel, stone, brick chips, etc., water and admixtures together. It is initially malleable in its wet state and solidifies over time, gaining strength and durability. The earliest usage of concrete was by the Roman Empire. The Romans used a mix of quicklime, pozzolana, and an aggregate of pumice. The British improved upon it and popularized it in the modern world. The Pantheon in Rome is one of the finest examples of Roman architecture that has survived to this day and has a 42-meter diameter dome made of poured concrete built in 120 AD. Concrete mixes vary based on strength, appearance, and local requirements. Depending on the application, there are a variety of concrete types that can meet your needs. An example is self-consolidating concrete (SCC), which is highly flowable and can spread readily into place without separating. The flowable aspect of SCC makes it ideal for precast concrete. Another example is polymer concrete, which uses a catalyst to bind aggregates together. It's pressed instead of poured and used in applications where a higher corrosion resistance is needed, for example, sanitary sewer manholes. Other types of concrete include high-performance concrete, pervious concrete, and shotcrete. Concrete is used as a construction material for almost all types of structures, such as residential concrete buildings, industrial structures, dams, roads, tunnels, multi-story buildings, skyscrapers, bridges, sidewalks, and superhighways, etc. Various structural members such as beams, slabs, footings, columns, lintels, etc. are constructed with concrete. Based on the variations in materials and purposes, concrete can be classified into three basic categories: lime concrete, cement concrete, reinforced cement concrete. In general, there are four concrete sorts of concrete such as dry ready mix, bulk dry materials, transit mix. Concrete is generally used in two types of construction. It is plain concrete construction and reinforced concrete construction. In PCC, it is poured and cast without use of any reinforcement. This is used when the structural member is subjected only to the compressive forces and not bending. When a structural member is subjected to bending, reinforcements are required to withstand tension forces structural member, and it is very weak in tension compared to compression. Generally, strength of concrete in tension is only 10% of its strength in compression. Examples of famous and large structures made with concrete are Hoover Dam, Panama Canal. It is the largest human-made building materials used for construction. Compared to engineered cementitious materials used for construction, the production cost of cement concrete is very low. It is inexpensive and widely available around the globe when compared to steel, polymers, and other construction materials. Fresh concrete is flowable and it's in a liquid state. Hence, concrete can be poured into various formworks or shattering configurations to form desired shapes and sizes at the construction site. Concrete can be cast into complex shapes and configurations by adjusting the mix. The amount of energy required for the production of concrete is low compared with steel. Also, there is excellent water resistance characteristics. Though chemicals in water can induce corrosion in concrete and reinforced concrete, concrete can withstand water without serious deterioration compared to wood and steel. Due to this property, concrete is ideal for underwater and submerged applications, like for building structures, pipelines, dams, canals, linings, and waterfront structures. Concrete has high temperature resistance. Concrete can withstand high temperatures better than wood and steel. Calcium silicate hydrate (CSH), which is the main binder in concrete, can withstand until 910 degrees. Concrete is a bad conductor of heat. It can store a considerable amount of heat from the environment. It is used to fireproof steel and used in high temperature and blast applications. Many industrial wastes can be recycled as a substitute for cement or aggregate. This includes fly ash, slag, also known as GGBFS or ground granulated blast furnace slag, waste glass, and even ground vehicle tires and concrete. Thus, concrete production can significantly reduce environmental impacts due to industrial waste. The quality of the structure is not compromised. Concrete structures do not require coating or painting for regular applications to protect weathering compared to steel or wooden structures where it is inevitable. One of the major advantages of concrete is its ability to be used in different application methodologies. Concrete is hand-applied, poured, pumped, sprayed, grouted, and also used for advanced applications like shotcreting in tunnels. Some disadvantages of concrete also include, compared to other binding materials, the tensile strength of concrete is relatively low. Concrete is less ductile. The weight of concrete is high compared to its strength. Concrete may contain soluble salts which cause efflorescence. With sustainable and green construction methods being top of mind, it's important to understand the role concrete has on the environment. Concrete can stand for thousands of years and gain strength as it ages, where other building materials can rot, rust, and bump. Thank you for your attention, dear students. Next time we are going to discuss metals. See you next time. Goodbye.